Good morning, Year 10. Today we're going to be solving quadratic equations by completing the square. But before we do that, let's quickly revise what we did last lesson, which was using quadratics to solve word problems. So question 1 says, find the height and base lengths of a triangle that has an area of 7 meters squared and a height of 5 meters less than its base. So first of all, I'm going to draw a diagram of this. So here is my triangle. The area of the triangle is 7 meters squared. Then it says the height is 5 meters less than the base. So I'm going to call the base x, which means the height is 5 less than that, which would be x minus 5. Okay, so because this is talking about area, I need to use the formula for area of a triangle, which is A equals half BH. Then I'm going to sub in the information that I know. The area is 7, and then that equals half times the base, and the height is the x times the x minus 5. Okay, now I just need to simplify the equation down, factorize it up and solve it. The first thing I'm going to do is times the 2 on the denominator of this fraction across to the 7. So 2 times 7 is 14. At the same time, I'm now going to multiply the x into that bracket. So that would be x squared minus 5x. Now we can see the start of my quadratic here. So I'm going to start with the x squared minus 5x, and I'm going to subtract the 14 over to the same side, and now that will be equal to 0. Now I can factorize that quadratic and use null factor. So I'm looking for two numbers that multiply to give the negative 14 and add to give the negative 5. The numbers would be negative 7 and a positive 2. Using null factor from that, from the first bracket, I get x is equal to 7. From the second bracket, I get x is equal to negative 2. Now remember, with word problems or practical problems, we have to make sure that our answers make sense. And if x was equal to negative 2, that means that the base of my triangle has a negative side length, which is not realistic. So we're going to disregard this solution because we can't have negative side lengths. And I'm going to restate my answer in a short sentence. So the question says, find the height and base of this triangle. So I'm going to say, therefore, the height is equal to, the height was 7 minus 5, which would be 2 meters, and the base is x, which is 7 meters. Question 2. A rectangular painting is to have a total area, including the frame, of 1,200 centimeters squared. Okay, so I'm going to draw this. Here is my picture frame. Inside that picture frame would be the picture. Okay, then the total area inside there is 1,200. It says if the length of the painting, so it's the painting inside the frame there, is 30 and the breadth is 20. So this is going to be 30 centimeters and this one down here is going to be 20 centimeters. Find the width of the frame. Now the frame would have to be the same width the whole way around. You wouldn't have different sized bits of wood or whatever this is going around the edge. So I'm going to call each one of these bits around here x. Okay, now that means the total length going across the bottom here of my frame would be the 20 plus the x on either side. So it would be 20 plus 2x. Then going vertically, I have 30 plus an x on either side. So it would be 30 plus 2x. Okay, so now I have that, I can find the area, because remember I was given the area of my frame. The formula for the area of a rectangle is A equals BH. My area was 1,200. My base and my height are these two things here that I've worked out. So it's going to be 20 plus 2x in brackets, and then 30 plus 2x in another bracket. Now I'm going to expand that out. So 20 times 30 is 600. 20 times 2x is 40x. 2 times 30 is 60x. And 2x times 2x is 4x squared. Now we have our quadratic happening in here, so I'm going to put it in order. The 4x squared should be first. 40 plus 60 will make 100x. And then I have 600 here, but I'll subtract the 1,200 across from the other side. So that would be a negative 600 equals 0. That looks like a non-monic quadratic, but it doesn't need to be because I can divide everything through by 4. So dividing by 4, I get x squared plus 25x minus 150 equals 0. So it's a little bit nicer to factorize. And that means that I'm looking for two numbers that times to give the negative 150 and add to give the 25. So that would be a positive 30 and a minus 5. Using null factor, I get x equals negative 30 or x equals 5. And as usual, we have to be careful of these negative answers because x represents the width of the frame and you could not have a negative width. So this solution is disregarded. So therefore, the width of the frame is 5 centimeters. Okay, so on to our new work for today. We have looked at completing the square before and factorizing to complete the square, but we want to go a step further today and actually solve equations by completing the square. So the reason we have this, if you remember, is because not all quadratic equations can be factorized. So completing the square method is one way of getting solutions or factorizing things when the solutions aren't nice whole numbers. So one thing we always had to do to complete the square was find the missing term or the third term in the quadratic that would make a perfect square. To do that, we simply halve the coefficient of the x and then square that. Okay, remember, when solving quadratic equations, write the equation making sure that the right-hand side is equal to 0. If it's a quadratic trinomial, is identified as the expression on the left-hand side and it cannot be factorized, find an integer factor pair and then factorize using the completing the square method. So to do that, we move the constant term to the right-hand side. This is part B, is the formula that we have. We halve the value of the coefficient of x and square it. Add this number to both sides of the equation. D, factorize the left-hand side as a perfect square and simplify the right-hand side. E, take the square root of both sides of the equation, remembering that there will be a plus or minus on the right-hand side. And F will complete the solution. So those are the steps, and hopefully they'll make a lot more sense when you see them in action. So let's have a look at question number 1. It says, solve each of the following using the completing the square method. So because it's an equation, we can do this a little bit differently to how we did the last section. So what I do first is I keep the first two terms of my quadratic, but the 2 that is the wrong number to complete the square, I'm going to move it across to the other side of the equation to get it out of the way. Then I'm going to take those first two terms and I'm going to complete the square using the half the coefficient of x and squaring it. So half of 6 is 3, 3 squared is 9. I'm going to add 9 to the left-hand side of the equation, and I'm also going to add 9 to the right-hand side of the equation. Now, I can factorize the left-hand side as a perfect square. To do that, halving that 6 is 3, so it'll be x plus 3 in brackets all squared. Minus 2 plus 9 makes 7, so just simplifying the right-hand side. Now, I can solve this by getting rid of everything that's with the x. So the first thing we get rid of is the squared. To get rid of a squared, you need to square root both sides. So square rooting gets rid of the squared on the left, but I need to put a square root over the 7. Now, whenever you square root, it could have been a positive or a negative number that would have given you that response. So if you think back to the very simple quadratics that we used to solve, things like x squared equals 16, to get x, you square it to 16 to get 4, but it could have been plus or minus 4. Because if you go in reverse, you go back this way, then minus 4 times minus 4 also gives you a positive 16. So just remember that. You need that little plus minus sign because there are two solutions here. Next, the positive 3, I'm going to move it across to the other side. So x equals a plus or minus 7 and then minus 3. Now, it's okay for you to leave your solution like that. But you may want to separate your two solutions so that you can see them. So the other option is that we could say we have a positive root 7, which is just root 7 minus 3, or the second solution would be the negative root 7 minus 3. So either one of those last two lines would be a fine way to leave your answer. Let's do that again in question 2. Same deal, we want to solve this by completing the square. So first of all, I need my 10x over here with my x squared. So let's go x squared minus 10x. And the minus 2, which is the wrong number, I'm going to move it over to the right-hand side, so equals 2. Next, I'm going to complete the square. So I take my first two terms, I take the coefficient of the x, which is minus 10, halve it, which is minus 5, and square it, which is 25. So I add 25 to the left, add 25 to the right. Okay, left-hand side gets factorized. Halving that minus 10, we get x minus 5 in brackets all squared. On the right-hand side, 2 plus 25 is 27. Now we're getting everything away from the x, so we're going to square root. X minus 5 is equal to plus or minus the square root of 27. Then add the 5 across to the other side. So plus or minus square root of 27 plus 5. Because that square root of 27 can be simplified, we should simplify that third. Square root of 27 is the same as square root of 9 times square root of 3. And the square root of 9 is 3, so we have plus or minus 3 root 3 plus 5. Often in textbooks, that answer is fine, perfect, you get full marks for that. Often they'd like to put the whole number first. They go 5 plus or minus 3 root 3, just changing the order, but that is the same thing. Or you could separate the two solutions again if you wanted to. Okay, let's do it one more time. Question 3. X squared minus 3 equals 5x. So the x squared's over here on the left. Let's move the 5x over, so minus 5x. And the 3, we want to move it over to the right, so positive 3 over on the right. Now we're going to complete the square. So this one's going to involve fractions, because half of minus 5 is either 2.5 or 5 over 2. And when you square, so if I write over here 5 over 2, technically it's minus, but I'm going to square it, so I don't really need the minus. And then I need to square that, which means I square the top to get 25 and square the bottom to get 4. So the number that I need is 25 over 4. Add it to the left and also add it to the right of the equation. Factorizing the left will always be half of that minus 5, so it'll be x minus 5 over 2 in brackets squared. 3 plus 25 over 4. Now, that makes 37 over 4. You can type that into your calculator if you like. Then, to get rid of the squared, I'm going to square root. X minus 5 over 2 equals plus or minus square root of 37, can't be made any nicer, but the square root of 4 is exactly 2. Then I can move the negative 5 over 2, move it across the other side, and it would make a positive 5 over 2. And I have a common denominator, so I could push those two things together to be plus or minus square root of 37 plus 5 all over 2, or you could have reversed the order of the things on the numerator there. You could have had 5 plus or minus root 37 over 2, which would be the same thing. Okay, time for you to practice in exercise 8H.